Hello everyone. Today we're going to talk about, or I guess we aren't, I'm going to talk about arithmetic sequences. So an arithmetic sequence is a list, terrible highlight job by the way, sorry about that, of numbers that follows a definite pattern. If you take any number in the sequence and subtract the previous number, the answer is always the same. And this value is called the constant difference. We refer to it as D. So first, we'll determine if the sequence is arithmetic, and then we'll find the common difference D. So the big thing to think about here is that it's always, you're always taking a number and subtracting the previous. So we'll take 100 minus 0, which is 100. 200 minus 100, so we're always going right to left, or bottom to top, depending on how your list looks, is 100. 300 minus 200 is 100. So yes, it's arithmetic because those are all 100, and our D, or our common difference, is 100. Negative 46 minus negative 38 is negative 8. Negative 54 minus negative 46 is negative 8. Negative 62 minus negative 64 is negative 8. Those are all the same. So yes, it's arithmetic. D equals negative 8. So here's a theorem. Basically, we're coming up with formulas for arithmetic sequences. So the general formula, the explicit formula, which you can use to find any term, is a sub n equals a sub 1 plus d times n minus 1. So essentially, a sub n is our nth term. So if n was 3, it'd be the third term. A sub 1 is our first term. D is our constant difference. And n is the term number. So to get any given term, you take the first term and you add the constant difference times 1 minus however many terms you have. Basically, it's n minus 1 because that first term was one of the terms. And the recursive formula is basically you say what a1 is, that's part of it, and then you'll say that an, any term, is a sub n minus 1 plus d. So a sub n equals the prior term plus the constant difference. As always, this ends up making, I think, more sense with numbers. So we have our sequence. We'll do our first term, our constant difference d. Recursive formula. The recursive formula depends on the prior term. Explicit formula you can use to find any term. So we have, so we have the sequence itself, First term A1, constant difference D, recursive formula which depends on the prior term, explicit formula which does not. So for this one here, 4 minus negative 1 is 5, 9 minus 4 is 5, 14 minus 9 is 5, 19 minus 14 is 5. So our constant difference then is 5. First term, you just look at the list. First term is negative 1. Recursive formula, first we say what the first term is, so a sub 1 equals negative 1. Then we say how you get a sub n, and it's always going to be a sub n minus 1, which is the term before, plus whatever our constant difference was, which was 5. Explicit formula, we can say, well, a sub n is going to be whatever our first term is, plus 5, which is our constant difference, times n minus 1. You can leave it this way, or sometimes we'll algebraically simplify it. So if we do that, we would end up with a sub n equals negative 1 plus 5 times n, which is 5n, 5 times negative 1, which is minus 5. So we would get 5n minus 6. So if you're asked for the explicit formula, take the one in the box. If you're asked for the simplified formula, then I would use the 5n minus 6. For this next one, 150 minus 125 is 25. 175 minus 150, 25, 25. So our constant difference is 25. First term in the list is 125. Recursive, start with A1, because that's basically how you'll, derive the whole sequence if you wanted to do it one by one and just keep adding the constant difference. First term was 125. A sub n equals a sub, and I'm saying sub like subscript, like underneath. That's what a sub n means when I say it. So a sub n equals a sub n minus 1 plus our constant difference, 25. For our explicit formula, a sub n, first term is 125, we start there, and we'll add our constant difference, 25, times n minus 1. If we simplified this, we would end up with a sub n equals 125 plus 25n, which is, well, 25n, 25 times negative 1 minus 25. So we'd end up with 25n plus 100. For this next one, negative 5 minus negative 2 is negative 3. Negative 8 minus negative 5 is negative 3. Negative 3. Then our constant difference is negative 3. Our first term is negative 2. So for recursive, look for a sub 1, just the first term in the list, negative 2. And then a sub n, be the prior term, a sub n minus 1. Well, could do a plus, but since it's really negative 3, I'm just going to make it minus 3. If you wanted to do plus a negative 3, you could. For explicit, a sub n equals our first term, negative 2, minus 3, or plus negative 3, either way, times n minus 1. If you're asked to simplify, or just because you feel like it, negative 2 minus 3 times n, which is 3n, and then negative 3 times negative 1 plus 3. So you would end up with negative 3n plus 1. So now we'll determine if the sequence is arithmetic, and if it is, we'll find the common difference, explicit formula, and the term named. So now we'll actually calculate the terms. So I'm going to rewrite it just so I can see it better. Negative 22, negative 31, negative 40, negative 49. Let's see if it's arithmetic. Negative 31 minus negative 22 is negative 9. Negative 40 minus negative 31 is negative 9. Negative 49 minus negative 40 is negative 9. So it is arithmetic. And our constant difference d is negative 9. Our first term is negative 22. So for our explicit formula, meaning we don't need to use the prior term, a sub n is our first term, which is negative 22, minus 9 times n minus 1. So that's our general explicit formula. Now we're asked to find a sub 20, so we're going to put in 20 for n. So a sub 20, which is our 20th term, is negative 22 minus 9 times 20 minus 1, which is negative 22 minus 9 times 19, which is, so a sub 20, or the 20th term, is negative 193. Let's look at the next one. So negative 20, negative 40, negative 60, negative 80. These are both technically going on, for our purposes forever. So to find our common difference, negative 40 minus negative 20 is negative 20, negative 60 minus negative 40, negative 20, and negative 20. So yes, it's arithmetic because all those differences match. D equals negative 9. First term in the list is negative 20. So now our explicit formula, a sub n, is going to be our first term, which is negative 20, minus 20 times n minus 1. Or what I'm doing here, this d is negative 20. Sorry about that, guys. So first term, negative 20, d is negative 20, negative 20 minus 20 times n minus 1. You guys would have caught that if we were in person. All right, so then to find the 38th term, a38 will be negative 20 minus 20 times n minus 1, which is negative 20 minus 20 times 38 minus 1, which is negative 20 minus 20 times 37. So a sub 38 equals negative 760. Couple things to keep in mind. Recursive formulas. So recursive helps us generate, so make new numbers in the sequence, or identify a sequence. So when we're finding the differences to see if they're constant, we're looking at it recursively, or when we're finding new terms. Explicit helps us find any term without having to find all the previous terms. So for example, if you want to find the 100th term in, I don't know, the sequence right here, you could subtract 9 until you got to the 100th term, or you could use this formula you found right here, and probably the formula is simpler, but technically both will always work.